Got to do this Indian thing. You would have been lucky because half of the kids in the back were just not even running up front. You're gonna be sucking half of it.
Well, obviously, if they're in the back, they're not running up front.
That's the point of the Indian.
All right, so after I solve that, I got to graph those two equations. Solve the first one. First one was good. Second one I solved for y. Put them both on the same graph now. So the first one, negative 2x plus 6. So I'm at plus 6 and I put a dot. My slope is negative 2. So this would be negative 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. Looks something like that. All right? Second equation. Just see this point here. I have y equals 1/3 x minus 1. So I'm at negative 1. 1/3 x is my slope. Up 1 over 3. Up 1 over 3. It's all the farther I have to go because they intersect. They intersect right there. Looks like the point 3, 0. That would be my answer. X is 3, y is 0. All right. The point where they cross at is the x and y value that satisfies both of these equations. Now then I can check it to make sure it works out for both of them. If I take the first equation, y is 0, so I replace y was 0 equals negative 2. My x is 3 plus 6. Negative 2 times 3 is going to be negative 6. Negative 6 plus 6 is 0. So 0 equals 0. That one's good. The second one, I'll just use the one that's written there. 3 times y, so 3 times 0, minus x. X is 3, plus 3 equals 0. 3 times 0 is 0. So I have negative 3 plus 3, which is 0. 0 equals 0. So that's good. Therefore, 3, 0 is my answer for this one. Questions? On the homework last night, it was due yesterday. Here's the answers to it. See if we need to talk about any of them. So what page? What numbers was it? 4. 3, 4, 5, 10 to 14, 16, 20. Okay. So 3 should be negative 1, 0. 4 is negative 1, negative 3. 5, you would get the equations y equals 10x plus 8 and y equals 12x. And then if after you graph that one with Desmos, you get the point 448. So if you buy 4 tickets, it costs you $48 regardless of how you buy them. 10 is 2, 4. 11 is 4, 9. 12 is 3, 2. 13 is 2, negative 2. 14 is 1, 2. 16 is negative 4, 4. 17 is negative 1, 3. 18 is negative 3, 5. 19 is 27 students and 3 students. And 20 is 2 years. Any questions on this? Can you see any of these? Which one? 17. All right, 17 we have. Let's do it right on here. Erase this real quick. Lose all of it. All right, so number 17, we are looking at 2x minus y equals negative 5, and then negative 2x minus y equals negative 1. All right, so the first one we solved for y. Subtract the 2x over. So I have negative y equals negative 2x minus 5. Now I want that y to be positive, so I have to multiply everything by negative 1 or divide by negative 1, whichever way you want to look at it. So it just changes the sign of everything. So y equals 2x plus 5. That's my first equation. Second one, solve for y again. So this one I need to add a 2x over. So I have negative y equals 2x minus 1. Same thing, I need to divide or multiply by negative 1, which is going to change the signs of everything. So y equals negative 2x plus 1. There's my two equations. So from there, graph those guys. Y equals 2x plus 5. So I'm at plus 5, up 2 over 1, up 2 over 1. Same thing here, you go in the other direction. Boom. Okay. There's that line. We'll extend it if we need to. Second one, y equals negative 2x plus 1. So I'm at plus 1. My slope is negative 2, which would be negative 2 over 1. Down 2 over 1. Down 2 over 1. Well, I need to go left. So I'm going to go left 1, up 2, left 1, up 2. Go in the opposite direction. They intersect right there. That point would be negative 1, 3. Questions? So what we're going to have happen today too, guys, I want to go on to the next lesson, but I also want some more review on this. So what I'm going to do is I'm going to put you're going to have two assignments from today. Essentially, if you want to look at it, one Thursday, one Friday. I'm going to have one that's a little bit more of this. We're going to still going to do the new lesson today, and then you'll have an assignment on the new stuff as well. Does that make sense? So then you have two assignments that you got Thursday, Friday, Saturday, Sunday to get to meet again then. All right? So let's move into today. So remember I told you we have three different ways to solve equations, solve two variables, two equations, right? I told you we're going to have three different types of tools. The first one we did was graphing. That's what we did the last lesson. We just went over. Second one is what we're doing today. This is substitution. And then the third one we're going to get to is elimination. And we'll do that guy on Monday. But we're looking at today, we're looking at substitution. Now here's the difference between these guys. The first one, graphing only works well if you're doing it by hand and it's small numbers. Honestly, okay? That's, keeping Desmos out of the equation. For graphing, you need to have graph paper, and you really want your numbers to be small. I think you guys figured out as soon as you got bigger than the number of like 5 in either direction, it's a little sketchy then, right? All right, so the biggest thing with graphing, it can be really inaccurate. Substitution and elimination, it doesn't matter what the numbers are, you can always get the right answer. Okay? It kind of takes out the inaccuracy portion of this. It doesn't matter if your line's straight or anything like that. All right? Now, as I told you before, as we go through these, and after you have all three, I'm going to tell you basically what to look for to use each type. There's going to be some where substitution is quicker, there's going to be some where elimination is quicker. I like substitution. Of these three, that's my favorite because it's the same every single time. Mostly, I usually have a few more kids that like elimination. And elimination, some problems are really short, some are really long. Substitution, every one of them is medium size. Does that make sense? So that's kind of why I like substitution the best, because it's the same every single time. So what's substitution look like? Substitution, we're just going back to our algebra days. We're solving some problems. I would write these down. All right, so here's your steps to solve using substitution. You want to solve one of the equations for one of the variables. All right, and I'm going to say box it. All right, that's my kind of way to remember that. You'll see that here in a minute. So solve one of the equations for one of the variables, then box it. And the second step, substitute what that value is equal to into the other equation. and solve for the remaining variable. Plug that answer back in the first equation. We can only solve one equation if we have one variable. That's the only way we can do it. There's no other way. All right? If we solve something, try to solve something with two variables, then you're just going to get those sloppy, unsatisfying answers. If we can make one of these equations only have one variable, then we can roll with it. We know how to solve something if we just have an x or just have a y. So that's what we're trying to do with this. All right, so you're going to take it, get one of the variables all by itself, and put that in a box. Substitute what that value is equal to in the other equation, solve for that remaining variable, and then plug it back into one of the originals. And what you'll see too, the way I do substitution might be slightly different than some other teachers, but I'm going to do a pattern. And if you follow this pattern every single time, you will not be run astray. I promise you that. This is a fun lesson. I think it's fun. You will not have as many problems for homework and stuff with these type because they are going to be a little longer. Okay. It's just kind of the nature of the beast. And this is definitely one of those lessons that you're going to be using this from now until the end of your high school career. For instance, this afternoon, no, not this afternoon, period 3, I'm teaching college algebra and trig, right? We are reviewing substitution and elimination at the end of college algebra. It's a half-year class. We're reviewing that. We're doing 2 equations, 2 variables today, and then next week we'll do 3 equations, 3 variables. All right, so it doesn't go away. I just did some substitution and elimination type stuff with my pre-calc kids last week. All right, so this stuff is going to be here. It's going to be here to stay. All right. We good with this? Ready to move? All right. This one here too, and there's the concepts are not crazy. It's not like you have something to memorize or anything like that. These are going to be ones that you just kind of have to practice. All right. So here's my 2 equations: y equals 4x minus 1 and 2x plus 2y equals 3. I was really nice with you to start, because the first thing we have to do, if we look at our steps, is solve one of the equations for one of the variables. Do we have one of the equations equal to a single variable right now? Yeah, we do. That first equation, right? First equation, I have y by itself. Okay? So what I would do, anytime I want to get a variable by itself, so if this wasn't already by itself, I'm going to take that equation, so we're just going to use the first one, and I want to write it down underneath this stuff. Okay? So y equals 4x minus 1. Then I would solve it for a single variable. It's already there. I'm good. Agreed? Y is completely by itself. Y equals 4x minus 1. So I'm going to put this, I'm going to box it. Okay, I'm going to put a box under this. So think of it, if I had, so last night in your homework, if you got x is 3 and y is 4 as your point, and then you wanted to check it, what did you do? Well, you took a 3, plugged it in for x, right? You put the 4, plugged it in for y. We just substitute those values back in. We've been doing that forever, right? Now, if I know that y is equal to 4x minus 1, I can plug that in for y. Okay? We have only plugged in numbers if it was a single number. I can plug in whatever it's equal to. Y is still equal to that. All right, so I'm going to come over to the side now. I'm going to take the equation I didn't touch yet, this 2x plus 2y equals 3. Okay? Now, I know that y is equal to 4x minus 1. We just found that out. That's in my box. So I'm going to take my box, and I am going to draw that arrow, and I'm going to plug it in for y. Okay, I'm just going to replace y with what y is equal to. So I have 2x plus 2 times my y. Well, my y is 4x minus 1. That's equal to 3. You all right with what I did there? That's the main big step of substitution. Get a variable by itself, then whatever that's equal to, plug it into the other equation for that variable. We good? So now the great thing is x whole number, x whole number, whole number. I can solve this guy now, can't I? I can solve it for x. So I only have one variable. We've been doing this, since the middle of the year. So let's go ahead and simplify. So I have 2x plus, well, I have to distribute here. 2 times 4x is going to be 8x. 2 times -1 is going to be -2. That's equal to 3. All right, combine like terms. So 2x and 8x is going to be 10x. All right. So I have 10x minus 2 equals 3. Almost there. What do I have to do now? Add the 2 over. Boom, add the 2. So I have 10x equals 5. Divide both sides by 10. So x is going to be 1/2. There's my first variable. All right. Got one. How many do I need? I need 2. Okay, so there's my first one. I'm going to go ahead and circle it. Now, after I got this one, I got the answer to the first variable, put it back in the box. Okay? Here, back to the box. So y equals 4 times, well, x is 1/2, minus 1. What's 4 times 1/2? 2. 2 minus 1 is 1. Boom. X is 1/2, y is equal to 1. And I could plug that right back in and check it just like I did yesterday. All right? Now, this pattern that you see on the board, I'm telling you, if you follow this pattern every single time, you are going to be in great shape. Okay? Here, find a variable, box it, plug it into the other, get your first answer, put it back in the box. Okay? Every time. It's like clockwork. Boom, 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 boom. You're going to be on top of things.
I'll have like 10 questions.
Probably not even that many. Any questions on that first one, guys? Anybody?
Nope.
Good? Yep. All right. Let's look at another one. Because like I said, these are just a kind of a repetition and practice type concept. So let's step one up just a little bit. So this one, I don't have a variable all by itself. Okay? First one, I had y by itself. I didn't really have to do anything. Just had to copy it down and box it up, right? Now looking at this one, I have x minus y is equal to 2, and then 2x plus y is equal to 1. I don't have a variable all by itself, but looking at that, I have 3 variables that are almost by themselves, right? Like I have just an x, I have just a y, I have just another y. Okay, so those are the ones I want to look for. So I'm just going to use this first equation, and x is positive, so how about we just get x by itself? Does that work? Okay, last time we had y by itself, this time we'll get x by itself. It does not matter. All right, so I'm going to take the first equation, x minus y equals 2. I'm going to get x by itself, so I'm going to add a y across, boom, boom. I have x equals 2 plus y. Do I have a variable all by itself now? Yes, I do. Box that puppy up. Right, and that was from the first equation. So, from there, take the other equation, the one you haven't touched yet, which is your 2x plus y equals 1. Now, be careful. Here is the biggest mistake people make. In the first equation, I had y by itself, right? And I plugged it in for y. This one, I have x by itself. What do you think I need to plug it in for? X. There we go. For some reason, everybody always, like, one person gets stuck on plugging it in for x. One person gets stuck on plugging it in for y. You know what I mean? I don't know why. It just happens. So, in the box, I have x equals. So I'm going to put it right there for x. All right, so 2 times 2 plus y equals 1. What x is equal to and for x. All right, so from there, what do I have to do? Distribute. Okay, yeah, you're still multiplying. You're multiplying the 2 through. Here, here. So what's 2 times 2? 4. 2 times y. 2y, and then plus y equals 1. Combine my like terms. The 2y and y is going to be good. 3y plus 4 equals 1. Now what? Subtract them. All right, let's subtract them from both sides. So I have 3y is equal to negative 3. Divide both sides by 3, so y is equal to negative 1. All right, I got my first answer. Put it back in the box. X equals 2 plus y. Well, I just found that y is negative 1. So 2 minus 1 is going to be 1. Boom. X equals negative 1. X equals, 1. X equals positive 1. Y equals negative 1. All right, so let's just check this one, just to make sure. Okay, that was the whole process of solving right there. Let's check it, just to make sure we did this right. So the first equation is x minus y equals 2. X is 1. Y is negative 1. Okay, so I'm going to end up with y plus 1, or 1 plus 1, which is 2. That guy's good. Second one is 2x plus y equals 1. So I plug it in. X is 1. Y is negative 1. So 2 minus 1 is going to be 1. So that one's good as well. Okay, but if you look at this problem, look at everything over here to the left when I solved it. Wrote down an equation, variable by itself in the box. Plugged it in the other equation, got an answer, answer back in the box, second answer. Same pattern every time. Yeah. If it says substitute, you will not have to graph. There will be, say I give you 10 problems, there might be 8 like this and 2 word problems. That's what you're looking at. We'll do a word problem here in a couple. All right. Any questions on this so far, guys? And this is the cool part about substitution. It's the same every single time. Okay? Same every single time. Boom, boom, boom. Same process. So, I put this guy up on the board. I want you guys to take, I don't know, 4 or 5 minutes here. And I want you guys to try this one. So this one here, again, like I said at the beginning, it doesn't matter which equation you use. So in this one, I see this guy in the second equation. It's almost by itself, so that's what I'm going to roll with. Okay, so I have 2y equals x minus 1. I want to get the x term by itself, so I'm going to add 1 over. So I have 2y plus 1 equals x. I have a variable all by itself. First step. Now I'm box that puppy up. Now I'm going to use the equation I didn't touch yet, which was 7x plus 2y equals 1. Now, I have x by itself, so I need to put it in for x. Okay? So I have 7, and then in parentheses is going to be, how about 2y plus 1? 2y plus 1 minus 2y is equal to 1. Distribute. So 7 and 2 is 14. 7 times 1 is 7. Minus 2y equal to 1. Combine like terms, so I have 12y plus 7 equals 1. So I need to subtract a 7 from both sides. So I have 12y equals negative 6. Divide both sides by 12. Y is going to be negative 1/2. There's my first one. Put it back into the box then. So 2 times negative 1/2 plus 1 equals x. 2 times negative 1/2 is going to be negative 1. Negative 1 plus 1 is going to be, so x equals 0, y equals negative 1/2. Now, here's the crazy thing about these problems, and I think you see as you're going. It looks like it's a confusing problem, right? Just from the casual observer. Looks like it's a confusing problem, but I'm going to tell you guys right now. If you're going to make a mistake, it's going to be 25% was because you plugged your variable in for the wrong variable. The other 75% is because you can't add or you can't subtract. Every time. It happens. How many people had that problem right there? They couldn't add or they couldn't subtract, couldn't multiply. You know, there's 4 basic things. One little mistake, all of a sudden we had, I heard you right away. 14 minus 2 is 12. 12? All right, 2 times 7 is 14, not 4. All right, I'll tell you, if you go back through, you start rushing. All right, you start rushing, and I mean fast, not the country. All right, you start rushing through these, you're going to make simple mistakes, and those will kill you more than anything. I promise you that. Take your time. Take your time with these.
I still be sleeping right now.
All right, next one. Let's do a word problem. This will be the last one we do, then I'm going to cut you loose on something to do on yourself.
Wait, we didn't even do elimination.
That's a whole nother lesson. Okay? All right, this one here. A snack bar sells 2 sizes of snack packs. A large snack pack is $5. So what it says? Yeah, $5. And a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many of each type of snack packs? Holy cow, that's like a tongue twister. Snack pack. All right. How many of each type of snack packs were sold? All right. Whoever we know, you bought over half of them, so. So, we have 2 different things to worry about here. One, we have the amount of money that we sold in one day, right? That's the big thing, how much money we made. The second thing is how many items we sold. Agreed? So those are the 2 things that they gave us. We got 60 items sold for $220, right? So let's look at it in 2 different equations like that. 1, let's worry about the number. 2, let's worry about the money. Okay? Those are the 2 different things we're looking at. So I'm going to do a money equation, and I am going to do a number equation. All right, that's where I'm going to get my 2 equations for, and I'm going to use substitution to solve. So let's do the number one first. That one's easier. How many did I sell in that day? I sold 60, correct. So I sold 60 snack packs. Now I have two different sizes. I got large and small. You just want to call them X and Y? So we'll say the large is X and we'll say the small is Y. Okay? So if I have total larges and smalls together, I sold how many? 60. So wouldn't that just be bingo? So X plus Y equals 60. I like that. All right, now we have to factor in that they're two different prices, correct? How much is a large? $5. So it'll be $5 times every large you sold, correct?
I got it.
Put your hand down. So we're looking at 5x. Now the second one, how much does the small one cost? $3. All right, so we have to add $3 for every one of those sold. The small ones are Y. How much did we make then? 220 big ones. All right? That makes sense where we got those two equations from. Okay? The first one, we dealt with the money involved. So $5 for the first kind, $3 for the second kind. We had to multiply that price by how many we sold for each one and set it equal to your total amount. Second one, we know that we sold 60 total items. So if we have item 1, item 2, the numbers sold, add them together, we got 60. All right, so let's solve this guy. I'm going to take the second equation. I'm going to get x by itself. Does that work? So x plus y equals 60. So let's subtract a y. X equals 60 minus y. Box that puppy up. Okay, got my first step done. Second step, take the equation I didn't touch yet, which was the 5x plus 3y is equal to 220. Am I plugging this in for x or y? Correct. It's going in for x. So I have 5 times 60 minus y plus 3y equals 220. So what's 5 times 60? 300 minus 5y plus 3y. Okay, and that's equal to 220. So combine my like terms, I have 300 minus 2y equals 220. So now I have to subtract the 300 over. So I have negative 2y is equal to negative 80. Both sides by negative 2. Y is going to be 40. So there's the first one. Take that one, plug it back in the box. X equals 60 minus 40. So I have 20. So how many small ones, how many big ones? Correct. So this is my big ones. And this is my small ones.
First off, I did 30
No, we don't
large
want to
ones.
estimate. We want exact.
Yeah, but I did 30 large ones, 30 small ones, and got over the price. So I went down and did 25 large ones and 35 small ones, and they were still over. So I went down and did 40 small ones and 20 large ones, and I got the answer.
Okay, what if you had like 17 and 43? Take you a while, wouldn't it?
No.
Yeah. We're doing substitution. Use substitution. What?
You said 220 big ones, right? For a bill, how would you call $1 bill a big one? I usually call it 20 big